All right, this is the last video in this particular sequence. I'm going to move things around a little bit so that I can see my graph a bit better. If this goes all the way out to 5 pi, and I don't think we need that much, so let's stretch things out a little bit so that we can see what's actually happening. I think I'll leave it to 3 pi just in case we need more than one cycle or more than one normal period, 2 pi. And I know that it's a cycle of 2 pi because this is either a secant or a cosecant graph. Here's my formula or my template, and I'm going to have to put either a secant or a cosecant in there. How do I know it's a secant or a cosecant? Well, years of practice for one, but if you remember that secant and cosecant are defined by sine and cosine, then actually if you take the graph of sine or cosine, whichever one it might turn out to be, and sort of use it to fill in the blanks here, you would get a graph that looks something like this. Now, this is not an easy thing to do, so bear with me. Yeah, that's really not a very good graph. It's coming from somewhere over here as well. So now let's see if we can find the midline, the amplitude, all of those things. Let me find the pen color that I want. Halfway between the minimum and maximum of this graph is the midline of both graphs. So there's my midline. My amplitude is given here, and my vertical shift is also given here. I can see my units over here. There's 1, 0, -1, -2, -3. So my d value is going to be -3. This graph has been shifted down 3 units. Let me replace my plus d with -3, -3. Actually, let me do that in a different color. I've been doing it in purple. Let's just stick with that. The adjustments that I make. Okay, so there's my -3. That's my d value. And my amplitude is pretty obvious as well, right? It's 1, 2, 3, 4. 4 boxes. Each box is an integer. Each box is a unit. So my a value is going to be 4. Okay, I have 2 of them. Now I need to decide whether this yellow graph is a sine or a cosine. And that will inform whether my graph, the graph I'm actually looking for, is a secant or a cosecant. I can think of it either way. I can either start, which highlighter do I have here? I can either start here, and that makes it a sine, or I can start here, and that makes it a cosine. And this graph appears to start about here. That's the yellow graph, and it's the yellow highlighted graph. The other one seems to start about here. Let me actually use a highlighter or something a little different here so we can see what's going on. I'm either looking for this value of x or this value of x. Well, neither one of those looks like it lands on a pi over 6 or a pi over 4. But let's just take a moment. Remember that I said I would give you values of c that were values that were multiples of pi over 12, and that probably 99% of them would be multiples of pi over 12 that were either pi over 2, pi over 3, pi over 4, pi over 6, or pi. So you might get 3 pi over 4 or 7 pi over 6, but you won't get a 7 pi over 12, for example, or even a 1 pi over 12. So if I take pi over 3 and 2 pi over 3 and add them together and find their average value, then I get pi, what did I get? Pi over 2. Pi over 3 and 2 pi over 3 are 3 pi over 3. That's pi. Divide that in 2, and that's pi over 2. So that's a nice landing spot. So it's possible that we could treat this as a sine graph that's been shifted to the right, pi over 2 units. It's also possible to take a different color, let's see, 2 pi over 3 and pi, and find the midpoint of that, find the average of those two values. Edit back. It's also possible to find a value somewhere between 2 pi over 3 and pi, but in this case it's very clear it's not at the halfway mark. So just finding the halfway mark here, finding the average of those two values isn't going to do it for me. So for that reason, I'm going to go with pi over 2. That means that my C value, wrong pen, sorry, is pi over 2. And since I've moved the graph to the right from y equals 0, from x equals 0 to the right pi over 2, it's going to be minus pi over 2 in my equation. All right, all that's left now, all that's left now is to find b, but I also need to use what I've done so far to determine whether I'm actually looking at a secant or a cosecant graph. Since I chose, I'm going to use another highlighter. Since I chose pi over 2 as my starting point, that means I'm using this graph right here as my base graph, my basis graph, the graph that everything's based on, all my values, all my shifts, my amplitude, everything. And that's a sine graph. And that means that my blue graph, which is the one I'm actually looking for the equation for, is a cosecant graph. Oh, this pen. Cosecant. This is really atrocious. There we go. Cosecant. All right, so I've decided it's a sine. My yellow graph is a sine graph, which means my blue graph, the one I'm looking for the equation for, is a cosecant graph. I found my amplitude, I found my horizontal shift, and I found my vertical shift. Now all that's left to do is to find the value of b, the number of cycles between 0 and 2 pi. Sometimes you can just trace that out. Let's use a purple highlighter. I'm going to stick with my yellow graph, and I'm going to say I've got 1. That's a sine curve. It's upside down, but I have a full cycle there, and that's what's important. 2. My yellow graph is very approximate, so I'm going to say that's 2. Remember, I said that these are all integers. A, B, and D are integers, so that makes this a 2. I'm using the wrong colors. That's okay. So there's my equation. Let me tidy that up. Y equals 4 times the cosecant of 2 times x minus pi over 2. All of that minus 3. All right, again, we're going to have to make a note of this somewhere and then come back and check and see if it matches the equation that's given by the parameters. Okay, are you ready? We were given secant. We found cosecant. That's okay. It could still be right. Notice that the b value we found is correct. The b value just tells you how many cycles there are between 0 and 2 pi. We found that there were 2 cycles of sine between 0 and 2 pi, therefore 2 cycles of cosecant. If we had chosen to do this as a cosine/secant graph instead, then we would still have found 2 cycles because sine and cosine, and therefore secant and cosecant, are just shifts one from the other. So we still found 2 cycles of our graph. We also found that the vertical shift was down 3. That would have happened whether we'd started thinking of this as a 1 over sine, a cosecant graph, or as a 1 over cosine, a secant graph. Those two values are the same. Lastly, for now, our a value is correct. And we could have ended up with a negative a value if we had started in a different place. But it would still have been -4, not negative some other number. So those 3 values are pretty much guaranteed, assuming you did all the work right, regardless of whether you think of this as a sine or a cosine, a secant or a cosecant. Now the difference is in the actual function that we were shifting versus the one we we actually worked on, the one that was given, the one that was graphed versus the one we worked on, and the amount of shift that we had to do, the horizontal shift, as a result of that. So what I'm going to do now is find a highlighter that I like. I think I'll use purple. And I'm going to treat this like a secant graph, which means using a cosine graph as my base graph. That means starting high or low and going from there. I'm going to start high because I want it to be a positive cosine graph. And if I think of that as one cycle of my base graph, actually I could do this one as well. Oh, my drawing skills are atrocious. Then I can see that the midline is -3, the amplitude is still 4, and my shift is to the right pi over 4 according to this right here. I'll come back to that in a second. And the secant graph is more visible than the cosecant if we think about this as our base graph. Okay, in the previous example, we were treating it as a 1 over a sine, so a cosecant. Now I did something a little weird in this case. I treated that, I left that as x minus c, which I've talked about before. It's common to see x minus c in that position because what that thing does is it shifts it to the left or the right. So it shifts the graph to the left or to the right, but it does it in the opposite direction than you think it's going to. So if we say x minus c, we're going to the right. But look at the c value here. We're actually going to the left. We're going the opposite of the right, if that makes any sense. We're going in the opposite direction to the right, as a negative c gives you a right. So we're going to the left. You can't see it on here because I haven't planned ahead very well. But right in here, right there, at this minimum value here, it's over there a little bit. That's pi over 4, negative pi over 4. So that gives us the correct value here. And we found our shift was to the right, pi over 2, but that's because we were treating this as a sine graph, a cosecant graph. So there's another one. And this one's a little bit different in that it's a secant or a cosecant, but really what I was doing here was working this whole time with a cosine or a sine graph, not the secant or cosecant. Fill in the blank with a secant, with a sine or a cosine, find the equation for that, and then just give the sine or the cosine, just change the sine into a cosecant or the cosine into a secant once you've found the equation of the sine or cosine graph, right? You find the equation of the sine or the cosine graph, that's your answer, but instead of sine or cosine, it's cosecant or secant. All right? I hope that's been helpful, and I'll see you in the next topic.